Hey guys, welcome to Selective Preparation Power Mathematical Reasoning for Test 27. Now, we're just going to go through a couple of questions from the test, and hopefully it helps you guys with your further tests as well. So let's just jump straight in. Question 2 reads, an alien from a far-off planet landed her spacecraft on Earth. She had left her planet with a full tank of super interplanetary fuel. She knew that she'd need at least 3/10 of that fuel to return home from Earth. She used 2/3 a tank of fuel to get here. She figured that she would still have, and this is the question we need to answer, of the original supply of fuel when she arrived home. Okay, this question is asking how much fuel she will have left, right, after she reaches home. So we need to know how much fuel it took to get here, and it was 3/10. So because the distance between her home and Earth is always going to be the same, it's going to be 3/10 to get there. Okay, if it's 3/10 to get there, and we use 2/3, guys. If we use 2/3, it means what? Used 2/3 means 1/3 left. Okay. That's the important thing of this question. 1/3 left. Meaning that 1/3 minus 3/10 is going to give us how much fuel she would have left after she reaches home. Wouldn't it? Okay. So after I do that, actually before I do that, I'm going to convert these into percentage. Why? Because the answers are all in percentages as well. So 1/3, and this should be common knowledge, is actually 33.3 recurring decimal place. With a percentage minus 3/10. 3/10, guys, and to convert that, 3/10 times 100. Remember when we're converting from fraction to percentage, we always times 100, is going to be 30%. Okay, so 33.3 recurring minus 30% is going to be equal to 3.3 recurring percent. Okay, that means that our answer is B for 3.3%. Oh, we rounded down, by the way. 3.3 is usually 3.3333333, right? But we just round down for the sake of this question, or maybe round to the nearest one decimal place to get 3.3. Question number 2. For this question, we're looking at two different scales here, okay? I'm sure you guys can read the question in your own, so I'm not going to go over that. But the question is asking, what is this question mark? Or how much does that box weigh, right? How do we find this out? Well, we start from this scale. We always start from what we completely know. And remember, guys, when we see a scale, okay, or any object that suggests or hints that two values are of equal value, then we know that we are dealing with an equation. Okay, because remember, if two things are balanced, it must mean that they weigh the same thing. So here I have 3x boxes, right? Plus that 9 kilogram or 9 units of weight, plus equals to 2x plus 17, right? This is what we're left with. And from this one equation alone, we can find out what x is, right, guys? So how do we do that? We subtract 2x from one side. So I'm going to minus 2x from both sides, minus 2x, to get rid of the 2x from the right side, minus 2x. If this is your question, well, why can't I minus 3x first? As in, why can't I get rid of the 3x to the other side? You can, but you'll just end up with negative x equals to some negative value. And just in case, I'm just using positive values. You can do that, and I'll show you later. But anyways, if I minus 2x from 3x, I get x plus 9 equals to 2x minus 2x is 0, so just 17. Here, x is therefore equal to, I'm going to subtract 9 from the left side, so I have to subtract 9 to both sides, and I get 8, okay? Let's try that if I did 3 minus 3x first. So if I did 3x plus 9 equals to 2x plus 17, and out of curiosity, I said, why don't I just get rid of the 3x first by subtracting minus 3x to both sides? Well, great. You get 9 on this left side, but you get minus x. Because remember, 2x minus 3x is minus x plus 17. And so if I move 17 to the left side, I get minus 8 is equal to minus x. Can you guys see how, yes, I can just cancel away the negatives and I get the same answer, x equals to 8. It's just a bit of a more difficult question where I have to be wary about what I'm doing. So I prefer not to do that, which is why I don't select this option. But if you were wondering, yes, it's exactly the same. No worries. Now, x equals to 8. That's all we need to know. And we move to the second scale. I happen to know that 3x plus 23 is the same thing as 2x plus this question mark that we have. If I know that x is 8, then I can just plug it in. 3 times 8 plus 23 equals to 2 times 8, which is 16 plus question mark. What's 3 times 8? 24. 24 plus 23 is 47. 47 then equals to 16 plus this question mark, right? So therefore, question mark equals to 47 minus 16, which is 31. Okay, guys? So hopefully that made sense, and that's why the option is E. Let's move on to this question. This question involves combinations, and it reads like this. There were 4 students sitting on the stage at school assembly waiting to receive their prizes. Alan and Julia wanted to sit together. If they did, how many different arrangements of students would there be? Now, I imagine an assembly looks like this with 4 seats, right? All facing the audience. If 2 students, Alan and Julia, want to sit together, that means 2 of these seats at one time wouldn't be available to the 2 other students, right? So there's 4 students, excluding Alan and Julia, there's 2 other students, right, guys? So those 2 students only have 2 seats to choose out from. The first seat can go to either of those students, okay? So I'm going to say 2 because there's 2 opportunities. And I'm not talking about who goes where. I'm not actually thinking about that. I'm talking about the opportunity for the students to sit. How many students can sit on this one seat? 2. Okay, it can either be one or the other, but I'm not really fussed about who does what at the moment. So I'm saying 2. But I know for sure that for the next seat, there has to be only one student sitting down because the first student that sits down here can't also sit here at the same time, right? It can only be one student left, the other student that didn't sit here. So this is how we're thinking about it. We're not talking about who sits where exactly. We're not thinking about that. We're thinking about how many different possibilities are there. And okay, so that's different. So in this one combination, I have 2 outcomes so far because 2 times 1 is 2. Okay, but that's not the only option. Alan and Julia can also sit here. It's the same here as well. Alan and Julia can also sit here. Okay, at the very last 2. And I don't include this one because they're not sitting next to each other. Okay, so that's not part of it. So anyways, I do that and I notice that the possibility of the other 2 sitting is the same. The first, let's just say 2 people can be seated here. And I don't mean that 2 people can sit on one chair at a time. I don't mean that. I mean that in this seat, it can either be, let's say, student A or B. That's what I mean by 2 over here, okay? It can be A or B. I don't really care. It doesn't really matter. I'm just looking at the possibilities or the total outcomes there are. But I also know that at the end over here, there can only be one student sitting down because the other one is sitting down here. Okay, so I times that. I also get 2. And how about in the last option? I also have 2 and 1. Okay, or 1 or 2. It doesn't really matter. And I get 2. So far, I have 2 times 3 of opportunities or possibilities, and that's 6. But there's one thing that we are forgetting here that will cost you the question. It's the fact that Julia and Alan can alternate or sit anywhere they want between those 2 seats. So if Julia was sitting here and Alan was sitting here, I can have Alan sitting here and Julia sitting here. And same for this. Alan, Julia or Alan, same thing. Alan, Julia or Alan. See how I have 2 extra for each option? So I'm going to times 2 to that. So I get 12. Okay, so this is the 12 possibilities or outcomes or arrangements that I have. Not the counting, and I didn't count by listing who sits where exactly. I'm just giving a rough possibility of who can sit where and how many students can sit where. Okay, and I got 12. Which is the answer. If this is too hard, you can list all the different combinations of students sitting down together. And that's completely fine too. I'm just suggesting this way because it's slightly a bit faster. Okay? If it isn't, that's fine. Just list out the students as well. Or different combinations. Let's move on to question 4. Fractions. Now this question, I'm sure you guys can read. The most important section here is actually the fact that we have 21 passengers left, okay? We don't know how many passengers there were originally, but we know that there are 21 passengers left, okay? So let's work backwards to find out how many passengers there were originally. At the third stop, 1/5 of the passengers got off and 5 got on, okay? So before 5 got on, right, how many passengers were there? There were... actually, let's start the equation here. So before 5 got on, there were 16 passengers. Okay? Right? And it says here 1/5 of the passengers got off, and then there were 16 passengers, right? Because that's what we just worked out. If 1/5 of the passengers that got off, right, and there was only 16 passengers left, that means that actually 4/5 corresponds to these 16 passengers. Where did I get the 4/5? If 1/5 get off, guys, then of the total, 4/5 is left. Okay? Does that make sense, guys? If 1/5 of the passengers got off, only 4/5 remain because there's the total of 1 minus 1/5 is 4/5. Right. So 4/5 corresponds to 16 passengers. Then how about 1/5? And I'll show you why I'm working out 1/5. 1/5 would then mean 4 because I just divided by 4, divided by 4. Right? Why did I work out 1/5? So that I can find out 5/5 or the total amount of passengers before they actually even got to this stop. So 5/5 would be times 5 from here. So 4 times 5 is 20. So great. I know that before this last stop, I had 20 passengers. Great. Now, let's look at the second last stop. In the second last stop, 4 passengers got on, right? That means that from the 20 that I had from before that I worked out, 4 had got on and it became 20, okay? 4 passengers got on and then it became 20 passengers in the bus, meaning that what? In reality, there were 16 passengers at that stop, okay? Before they got on. But there were only 16 because 1/3 of the passengers got off, right? Beforehand. And so I do this corresponding thing again. So if 1/3 of the passengers got off and I had 16, that means 2/3 must be equal to 16. Okay? Because 1/3 got off, 1/3 of the total amount of passengers got off, that means I have 2/3 left. And 2/3 happen to be 16. So if 2/3 corresponds to 16 passengers, then 1/3 is 8 passengers, then 3/3 or the total before this stop must have been 24 passengers. Okay? Excuse me. Okay. Now, the first stop. We're at the first stop now because we're working back in time. At the first stop, half the passengers got off and then 8 new passengers got on. If 8 new passengers got on, and there were then 24 passengers, that means that before the 8 got on, I had 16 passengers. Okay? And then before that, half the passengers got off. If half the passengers got off, guys, and then there were 16, then that must mean that 16 must be the other half that was remaining. If 16 is the half, then before the first stop, I must have had 32 passengers. Okay? And that's how I evaluate or work out how many people stopped at ride, which was B, 32. Okay? This is actually kind of tricky. Or once you get the concept, it's not tricky, but it takes a long time or hard focus to really think about what you're doing. So yeah, I recommend this strategy for 7. Either that or you can guess and check, but I wouldn't teach that because you guys know how to do that. Question number 5, meters per second. The circumference of a wheel is 40 centimeters. The wheel revolves 3 times every 5 seconds, 3 times per 5 seconds. That means that the speed in meters per second on the point of edge, blah, 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 would be, and so if it rotates 3 times every 5 seconds, then every 5 seconds, it actually travels 120 centimeters per 5 seconds, right guys? Because remember, 40 centimeters. Now, if it's 40 centimeters or 120 centimeters per 5 seconds, that corresponds to 1.2 meters per 5 seconds. And since the question asks meters per second, then I'm going to divide this by 5. Then I also must divide this section by 5. Okay? If it's 1.2 meters per 5 seconds, then in 1 second, which is 1/5 of that, must be corresponding 1/5 of 1.2 meters, which is 1.2 divided by 5, which is 0.210 204, so 0.24. Okay, 0.24 meters per second, which is why the answer is C. Right, key points from this test, guys. Point number 1, convert fraction to percentage by multiplying 100. Where do I get this? From this question. First question we did. Remember how I converted 3 out of 10 to percentage by timesing 100? Fraction can only be converted to percentage by multiplying 100. Now, next, a fraction off of something means that there is 1 minus the fraction left of it. Now, this is confusing, but from this question, you would totally understand what I mean. If 1/3 of the passengers got off, right? Off, then I have 2/3 left. I get this 2/3 how? 1 minus 1/3 is 2/3. And that's where I get this 2/3 from. Okay? So let me repeat that. A fraction off of something means that there is 1 minus the fraction left of it. And usually, in these kind of questions, it helps you more than the fraction off of something. Now, point number 3, use the definition equation means equal on both sides to your advantage. What do I mean? Look at this scale, guys. Remember, any object that hints at an equality of something or an equal value of two things, then we can straight away see that the question is referring to an equation. And this equation here happened to be 3x plus 9 equals 2x plus 17. And use this to your advantage so you can waste no time in figuring out how to solve the question. Okay? And yeah, guys, that's it for today. I hope you learned something and can take it to your